Hi Spring fans! In this installment of Spring Tips, we're going to look at Spring Statemachine. Now Spring Statemachine is a project that allows us to describe just that, state machines. Basically things that contain well-known, well-understood transitions from one state to another. You have probably built a million state machines in your life if you've ever done any kind of programming at all. Any kind of if then else statement, for example, at some point will constitute a state machine. A case statement constitutes a state machine. Anything where you have orderly sort of transitions, predictable deterministic transitions from one state to another and then have action associated with that, that's a state machine. So a state machine is a very fundamental part of what we do. But as often as not, it boils down into these ugly sort of if statements or else statements and things like that. And worse, if you have complex state, then you have to evaluate that state at the site where you're keeping this, where we're actually processing the state, as opposed to at a higher level. So it becomes very useful to extricate the flow, the progressions of the business logic from one state to another into a separate plane, a separate place where you can model it, where you can reason about it, and then have the code, the actual business logic that's associated with that, respond to those state changes, right? So you've got, instead of a bunch of business logic where you have a whole bunch of if-then-else statements at the site where you're making the decision, deciding what to do next, instead of having that, you keep this business logic in a single place and then have actions or handlers or whatever, or some way of describing what should happen based on that state. This is it's useful because if you want to change the workflow, if you want to change the progression of one thing to another, you can do so in a single place, as opposed to having to scour all the different layers in the code base where you have all these complex decisions. So state machines are valuable for that reason. They also give us a nice way to think about the progressions of our application, how things should happen, how they should move. Modeling your business logic in terms of a state machine is a very useful idea, even if you don't plan on using at the code level a state machine, right? And this is, for example, why UML has support for describing state machines, right? State machines are a very, very important part of what we're doing. At some point, people want to connect business with the code, and a state machine provides a logical place where both business and technology people can sort of interface, right? The business heuristics, what it makes sense for our business as an organization, can be modeled in terms of a state machine, and then that can be translated into code. State machines give us a way to describe state as well over long running process, right? So if you have a long running process with lots of moving parts, it can be very useful to be able to look at something and say, oh, where are we in this progress, right? In this process. So if any particular one step in the process should fail, we can look at the state machine to say, okay, we should resume from here, right? We're on step 2 of 5. State machines have the benefit of being queryable. You can interrogate them. You can ask them, where are we in this fulfillment flow, for example. Suppose I'm fulfilling an order or something like that, and we have a number of steps involved in doing that, from both people and autonomous actors. Being able to poke at the state machine and go, okay, we're on step 2, what happens next? Okay, this is step 3, and so on, is very, very useful. So state machines give us a lot of benefits. They're convenient as a way of interchanging ideas between technology and business. They're convenient because they give us a way to keep track of the progression of some sort of work, especially useful in a distributed system scenario where you have potentially a lot of moving parts, a lot of actors in a system, and you want to be able to understand and track their progression, their activity. So state machines are fundamentally a very simple thing. If you take this idea a step further, if you have this idea that you want to extricate the state or the movement from one state to another to a higher order construct, you see a lot of different options out there, and a lot of them tend to be fairly heavy workflow engines or business process management solutions. And I think that would be a good subject for another installment, certainly, right? I've done talks and articles and so on, for example, activity in Spring, right? Activity is a BPMN workflow engine that you can use with Spring Boot, and these days, actually, activity has a few forks. So Camunda has a fork of it. A new company called Flowable is based on activity as well. So there's a lot of interesting sort of fertile research just being done in that one particular corner of the BPM and Universe, not to mention all the other implementations out there. So there's certainly a lot there we could talk about in other installments. But today I want to focus on a much lighter weight project called Spring Statemachine, which gives you a very simple DSL for describing state machines. That's it. And you can do things like persist the state of the state machine if you want. You can describe complex hierarchical progressions and transitions if you want, but all these things you have to add extra, right? By default, it is just a DSL for describing states and their progressions and what events can activate those transitions. So we're going to go ahead and build a brand new project here today and at the normal place here. So let's see. Okay, start.spring.io. We'll build a new application. We're going to call this order service. All right. And we don't need anything here except for perhaps the web support. So let's go ahead and, well, I mean, I'm not even sure if we need that, do we? Yeah, we don't need it. Let's leave it off. So we'll build an application here and hit generate. You know, I do want some stuff. I want JDBC, I want JPA rather, and I want H2. So let me kill the errantly downloaded version there. Okay, so we want JDBC, JPA, and I think that'll do. I think that's on Lombok certainly. Okay, very good. So now notice that right now there is no checkbox, and I think that'll change pretty soon. Well, if not, I'll certainly add one. But in the meantime, we'll just have to add it ourselves. It's just one little dependency. It's not a very large dependency. It's not a whole ecosystem of projects. It's just one library. One project rather, one small project with a few interesting modules. You can use it if you want, or don't, right? I happen to like it. I think it fits a very nice, space. There's a really nice space for describing complex transitions and for reconciling those transitions. If you've ever used the Saga pattern, right? The Saga pattern requires you to have a Saga execution coordinator, and you could model that with Spring Statemachine, for example. The Saga pattern is a great way of building. Of achieving consensus across multiple, workloads, across multiple units of work in a distributed system, or at the very least in a long-running single-node transaction. So that's a good example, right? You could use the Spring Statemachine to achieve that. You could model more complex business processes that need some sort of representation separate from the actual implementation. You could do that with Spring Statemachine as well. Okay, so let's suppose we have a very simple order service. Okay, so we're going to first add our dependency here. Now, I have the font a little too small there. Let me make the font just a little larger. All right, 22, good. And we're going to go ahead and add Spring Statemachine. I have, for my own purposes here, kept the dependency off to the side. And we'll add that here. All right, 1.2.3. 1.2.3 is Spring Statemachine. That's the version we're going to use. And so we're going to create a new service. Now, before we do that, let's actually configure the state machine itself. So the first thing we need to do is to create a configuration class. I'm going to say class simple enum state machine configuration extends state machine configurer adapter, right? And what we're going to do is we're going to model a state machine that has well-known states that respond to well-known events. And this is going to be a common thing. You'll see this a lot. And so the states you need to, you can describe those states in terms of strings, or you can describe them in terms of enums, which I think is actually a much more sort of palatable option here, because it gives you a nice type-safe way of describing well-known states. So enum order states, and we're going to say that there's a when somebody makes an order on some sort of e-tailer website, you'll have an order that gets submitted. So we're going to say submitted and paid and what else? Fulfilled, I guess. That's when somebody, takes the order, puts it in a box, labels it, stamps it, sends it out, or canceled, right? So whatever reason, you might cancel the order, and we could have more complex business logic here around when somebody's allowed to cancel it. But let's just say for now that you can cancel it at any time. And then there are events, well-known events that trigger these state changes. So, for example, when somebody sends the pay event, then it goes to the paid state, right? So we want that. When somebody sends the fulfill event, it goes to the fulfilled state. And of course, when somebody sends the cancel event, it goes to the canceled state. So now, with that done, we're going to say that we're going to build a state machine with these order states, right? It's states are first and then events are second, so order events. All right, now this is a configuration class, and we want to use the @enable state machine factory, right? This is the this refers to the ability of Spring Statemachine to either keep one sort of global state machine or to vend new instances of the state machine for whatever your purpose is. And I want to actually vend different instances, so I'm going to use the factory mechanism here. Now it's worth understanding that there is actually, you could use the Spring Statemachine project without Spring, right? I'm using it with Spring because I think it fits there, but it is such a simple library fundamentally that there's just a builder DSL that you can use, but I think it's fine to use it as is with this. So first thing we have to do, we have two things that we need to do, three things rather. First, we need to configure the engine itself, right? And so we'll override the configure, let's see, state machine configuration configurer is the engine itself. And here we're going to say config dot, I want to change the configuration, we want to start it up automatically, set that to false, and then we want to specify a listener. And actually we don't need this right now, but we could provide a state machine listener, right? And so here we'd have something that we can use. So it's a state machine listener. Let's see, it's order states, order events, and we override any one of these interface methods, right? So I've got the adapter here, but if I were to override the interface proper, I'd get a number of different callback methods. One that's kind of interesting from I think is the state changed method. So state changed or entered or exited, right? And so this allows us to see when the state machine has gone from one state to another. So let's actually extract that out into a separate class there, and we can actually store that, right? We don't have to keep this. Actually, it's fine. We can, yeah, there we go. So there we go. There's my simple adapter. These are no operation based interface methods, so you can do whatever you want in there. All I'm going to do is I'm going to log it, and I've got lumbuck on the class path, so I'm going to use @log to generate a logger, and I'll just log. I'll say log info state changed, and the from will be something, and we'll talk about that in a second, and then to will be something else, and then this. So let's see, string dot format, and we're going to say from dot to string, or actually let's do from plus, okay, and then to plus. All right, so there's our simple listener. This is actually pretty, you probably don't need to do this first, but it's always nice to, I like to have it, since we're using the factory, we don't want it to start up a state machine, a global one when we start the application. So we'll disable that immediately, first thing. Now, the next thing we want to override is the state machine states themselves, right? So we need to actually tell the state machine about the different states. So we use the state machine state configurer, and we'll say states dot with states dot initial. So what we're going to do is we're going to provide a directed graph. We're trying to describe what states can come, which states are the sort of genesis of a state machine, which ones are the termination, and which ones are progressions, right? Which ones are actual states that can be kept or maintained or whatever. So, and we can do complex things here. We can do splitting and joining, and we can describe custom things here. But for our purposes, we just want to describe which one is the initial one. So the initial is going to be a submitted, right? So order states rather submitted. That's the first state that our state machine will be in when it starts up. We're going to have another state called order states paid, and then there are two terminal ones, and one is called order states fulfilled, and another one is called order states dot canceled. All right. So there's two different states that can finish the finish the workflow. So we can either end correctly on a fulfilled, or we can cancel it, right? These are both terminal conditions. The workflow, the state machine is done if we enter either of those states. All right, now finally, we need to actually describe the transitions from one state to another. So here, we'll use the state machine transition configurer, right? So let's see, that is this one here. And here, we're going to say transitions dot, and here you can see there's a lot of different types of transitions, right? A lot of different ways a lot of different ways for transitions to be triggered or activated, and a lot of different kinds of transitions themselves and things that you can actually do with them. So if you, for example, had a state machine that just it went from start to, A to Z, right? If you had from A and then B and then C and then D directly with absolutely no intervention at all, that'd be called a local transition, right? You could say with local source, and then the source would be, let's say, for example, order states dot submitted dot, and then the target would be order states, what do we say, fulfilled? Yeah, fulfilled. So that would be, if we were to create a state machine like that, it would start up, it would go from submitted directly to fulfilled, and it would just be automatic. As soon as the program started, it would continue doing that, which isn't that useful. Usually, you want to, unless you want to automatically advance the token, represented, or the token representing each state. If you want to automatically advance it to the next state when the application starts up, or based on it having entered some other state, then this is probably useful. But in our case, we can, we want our state machine to change only in response to some sort of event. So far more commonly, I find that I use with external. So with external gives you three options here in the DSL. So you'd specify the source. So one source is submitted, right? And the target is going to be paid, right? And then the event that can trigger that transition is the pay event, all right? So that's one, state transition that we care about. Another one is and. Here we're going to say source, or dot with external first, dot, let's see, keep this a little cleaner. Let's try it like that. There we go. So source, paid, target is fulfilled, and event is fulfill. All right, there we go. That's another progression. So it'll go from submitted to paid with the pay event, and then from there it'll go from paid to fulfilled with the fulfill event. What else do we want? With external? And with external source, order states submitted to cancel. So we want to be able to support canceling at any point, right? So canceled based on the cancel event. Cancel. All right, and we're going to duplicate that again here for the paid. If it's in the paid state, we want to be able to cancel it as well. So here, paid to canceled based on the cancel event. And then finally, we're going to cancel it if it's in the fulfilled state, right? So with external dot source fulfilled dot target will be canceled, and then event will be cancel. All right, there we are. So there's our numerous different states here, right? It's going from submitted to paid, paid to fulfilled, and then filled, of course, is our final one, right? So that's a successfully finished workflow or state machine. We also have submitted to canceled, we have paid to canceled, and fulfilled to canceled. And one could argue that this isn't very useful, so maybe we'll actually get rid of that one, right? It doesn't. I'm not sure if that one's all that useful since they're both terminal states. But okay, so there we go. There's our states, and that is our that's it, right? We've configured a single state machine. It's a lot of configuration, but you get a working result. So let's actually try it out. Let's actually use the state machine and just advance it, right? Let's just use it to move data, to move the token represented by the state machine from one state to another. So we're going to actually create a command line runner that creates that takes advantage of a state machine factory. So class runner implements application runner, and we'll inject our private final state machine factory, order states, order events, factory. All right. Enter that. All right, good. Look at that. So this dot factory dot get state machine. This dot factory dot get state machine. So that's it, actually. That's the result there. We have a state machine. We have a new instance of the state machine. We can also provide a unique ID if we want to like have multiple instances. So maybe you have a state machine for a particular order number, right? Order 75, whatever, right? Whatever you want to be able to correlate, or to be able to correlate the state machine to whatever external state you've got. So let's see what happens. Let's interact with this. So machine dot start, right? So let's hit start, and then we'll say machine dot get state, and that'll give us the current state, and we're going to get the ID and then the name, right? So let's print it out. Let's actually log that out. So we're going to say @log, and we'll go down here, log.info, current state is that, all right? Run the code. All right, what did we get? So the state changed. We saw the listener there. State changed from null to that's the first one, to object state submitted. Right. So when it first started up, it automatically goes to the initial state, which is submitted. We can see that the machine has actually started. And so these are the different states. The current state is submitted. Here's the UUID for it, and there's the random ID that we gave it. We printed out the current state. It said submitted, right? And that's it. The program finished at that point. So let's keep going now. Let's say that we want to trigger the movement from fulfilled to paid. So now we can send an event. We can do it a couple different ways. We can say order events, and then just pass in one of the events. So order events dot fulfill. That'll give us more. So now let's put that down there again, and we'll run this application. All right, so if we look at this, current state, again, submitted. Uh-oh, what did I do wrong? We said, oh, it's submitted. We have to pay, don't we? See, I can't, that's a good demo. I can't go from submitted to fulfilled. I have to go through the predictable, well-known states here, right? It's not going to let me enter an invalid state. So I'm not going to be able to do something that's outside of the design of the state machine, which is exactly what we want, right? We want a predictable, deterministic progression. We want to know that it's not possible to accidentally arrive at too far ahead in the processing without all the preconditions, which is to say all the previous states having been satisfied. So there we are. Current state equals paid, right? So we know we got that. That's the second time, right? The first state was submitted, and then it says paid. Now let's send another event, send event, and this time instead of using the Enum object itself, we'll send a message using the Spring Framework Message Builder. Spring Framework, the Spring Framework Messaging Message Builder. This is the same message builder that you use for Spring integration. It's the same one you use for the WebSocket support and Spring MVC. It's the JMS messaging template and the JMS and the MQP messaging template and all that stuff. All use the same basic thing here. So I'm going to say with payload. And what are we going to send? The payload is going to be, of course, an event, order events dot, we want to fulfill, right? Oops, fulfill. And we're going to build that. And the reason this is important is because you can actually craft, reason that we have the second variant is because you can craft a message that has headers, right? I can say set header A equals B, right, for example. And as we can see, as we'll see in a bit, those headers can be useful in your code, in your component logic. So let's move that down here and then run the application. And let's see, here we go. Awesome. Okay, so we can see the current state is now fulfilled. All right, so we've gotten the fulfilled support, that we've got submitted, paid, and fulfilled. That's working as expected. We can interact with the state machine at any time, and we get a sort of a well-known thing, a well-known quantity. All right, that's all very well and good, of course, but it is, at the end of the day, just, you know, we're just moving state around in memory. We're not doing anything based on it, right? We're not actually acting on it. So you have a couple of places where you could do that. First of all, you could actually provide state entry handlers, right? So you could say, based on whenever somebody enters the submitted state, you have a handler. So a new action looks like that, right? So your job is to do something that reflects that we're in the state. Maybe you want to write a record to the database. Maybe you want to send a notification or send a message on a queue or whatever you want, right? So entering submitted state, right? And you could have new data, right? You could actually have data that is encoded in this order. So you might have data that comes from the message that we talked about earlier. You could actually pull that out here. So if you wanted to. So the context, get event, right? This is the event. Get extended state. You can get variables, right? So I can get order ID if I want to. Get or default. So let's say it's -1 long order ID. So I'm now class.cast. There we are. So this is me extracting out either a -1 or an order ID from the extended state in the state machine. So let's actually let's see if we can send that into the state machine before we start it up, right? So here we go. Entering state machine. Order ID is, and we'll write out the order ID. Okay. So now we have to actually send this order ID. That's a precondition for this to work, right? It's going to fail. It's going to blow chunks spectacularly if we don't have that order ID. So let's go back to our state machine here before we kick it off. Get extended state, get variables, put if absent order ID, and we'll actually extract that out into a separate value here. So we'll say long order ID equals this, and we'll put this in here. We'll say long.toString order ID. We'll put order ID in there. So we're putting that in there before we launch the process, before we launch the state machine. Let's now run this again and see what we get. All right. So if we go here, okay, order ID is 13232, just as we expect, right? Entering submitted state. So here we have the ability to propagate, to perpetuate state from one node to another in the graph, in the state machine. This is very convenient. You can do all sorts of handler logic there, and that handler logic, it can be here, or you can just call another function. You can call another thing, right? So you could actually use Spring integration here. You could use Spring batch. You could do whatever you want to, but you can maintain sort of this well-known progression of state. Spring State Machine is useful, by the way, for all these. Like I said, it's particularly useful, I think, in these long-lived sort of distributed transactions or distributed worker scenarios where you have lots of moving parts that have to coordinate their state. Okay, so this is how you would provide your own custom behavior, right? Okay, so that's convenient. I want, we've looked now also, by the way, at how to launch an instance of the state machine and to how to activate it. Let's go ahead and comment this out now, and let's actually wrap a service around this machine, a service that manages our entity for us and does things. It's got some semblance of business logic. So we're going to create a order service class. It'll be an order service class, order service, and we'll use JPA here to describe an order. So class order at entity, and it's going to have a private long ID, private. What else do we need? I guess the ID is actually all we really need, isn't it? So date, we could say date time, whenever the job was, whenever the order was made. So that's the essence there. We need the ID and at generated value. All right, so we want that, but of course, in order for this to be useful, we need getters and setters. So we'll use lumbuck again, all args constructor, at data, get the getters and the setters and all that stuff. So this is JPA. These three are lumbuck, right? Okay, let's see. Okay. So we have that. I guess we need a repository now. So let's go ahead and build a repository. Interface order repository extends JPA repository. Managing entities of type order whose primary keys are type long. And we want to actually use that in our service. So in our service, we're going to inject the repository, private final order repository. And our service is going to have a few different methods, right? A few of them are, I think, fairly obvious. Let's look at the first one, which is order. We're going to actually create a order when somebody gives us a date, right? I guess that's the only thing we need for our date time after all. So we're going to say public order. Actually, it can just be order. It doesn't really matter, does it? We're going to have a new method here, order. So given a, we could call this create or something, I guess. There we go. And we'll say when somebody gives us a date, we're going to create an order. So we can say return this.order repository dot save new order, and the first parameter is the ID, which we don't need. We also should have the actual state, shouldn't we? Right, our order is going to progress from one state to another, so we want to manage that. So let's talk about how we can persist that state. We want this order to go through a well-known state, and those can correspond to the states in the state machine. So we're going to store it as a string, but we're going to actually create a constructor, and we're going to create a constructor that can take our enum values. So we're going to say date D, and then the order states OS. So this dot date time equals D, this dot state equals OS dot name dot, okay? So this is the string representation of the enum. This is a Java-ism, right? All enums have the ability to produce a name that corresponds to basically to the symbol that you see in the enum itself, right? So in our case, it'll be fulfilled and all that stuff. All right, so maybe we'll make that public. Good. And the ID, of course, will be auto-incremented and generated for us by JPA. So let's use this new version here, this new constructor, and the order state will be, of course, submitted, right? And I'm cheating a little bit there. I should perhaps check a state machine, but let's assume we already know, we can take that for granted, that all orders when they start are at the order state submitted state. So very good. And we might even have some getters and setters for that. So public order state get order state, return this dot state. I'm going to say order states dot value of, right? I'm going to get that string and use that to arrive at the enum, and we're going to have a writer as well. Set order state, taking in the order state and writing it out. So this dot state equals s dot name, same as before, and we could even just use that setter here, set order state OS. Very good. Okay, so now we need to manage that state. We need to actually manage the state machine. So let's imagine in our runner, we're actually going to call that order service here. So let's go to our runner. Where is that runner? It's up here. I'm going to move our order service a little bit closer to our work. Up here, close to the runner, so we can actually bounce back and forth with a bit of ease. All right, so there we are. The order service is just above the runner. We're going to get rid of all of this since we understand what's happening there, and we're going to make it a little easier to keep everything in sight here. So I'm going to move this to the top so we can bounce back and forth. This runner will be our simple little test, and we probably should just write a test, but let's just keep it in the same code page here, shall we? All right, so order will be a order. I'm going to use the order service. So we'll say order service. We'll inject that. We don't need this anymore. Inject the order service. Order service. Add the constructor. Get rid of the factory. That's in the order service. It's buried in the order service for us. I'm going to say this.orderService.create new order service. Okay, very good. So there's our order. Now, let's suppose that we want to change that order, right? Maybe we have different business logic events, right? We could actually have, somebody clicks on a button, so then we want to make sure that the workflow moves to the paid state, right? And then somebody, maybe they filled out the form and they've filled out the credit card information, so we want to make sure that the state machine reflects that it's been paid. And then finally, a day later, a label's been printed out and put on a box, and the order is now fulfilled, right? So we want to make sure that when they click that button on their mobile phone in the warehouse, that the order reflects that state as well. So we need some way of telling them, we're going to imagine a number of different methods. We're going to go ahead and just implement one sort of omnibus method here that moves the order from one state to another. But you can imagine having the same basic logic, reused across different bits of functionality. Different. It's a backing service that different clients will talk to. So let's go ahead and do that. We'll create a method here called change. Okay, so change is in our order service over here, and the change method will return the state machine itself, right? So we want to actually have the state machine itself, but I think in order to do that, we're going to actually need to have a method that actually builds the state machine for a given order. So let's start with the business logic thing, the business logic focus thing, which is what we should care about here. That's the that's this, and we're going to order ID, and we're going to have an order events parameter here. In order for this to work, we're going to need to have a way of arriving at the state machine. So SM, and we need to arrive at the state machine. So let's just say this.build, and we're going to pass in the order ID and create that as a private implementation method here, because there's a lot that needs to happen here. So first things first, we need to look up the record. We need to look up the ID here. So actually first, let's return that, make that compile. And to do, there's some stuff that we need to do there. But first we need to vend a new instance. So we're not going to actually persist the state machine itself, but we need to rehydrate a state machine. We need to factory a new state machine based on the order, and then push it to a certain state, right? If the order reflects the fact that that it's already been fulfilled, then we want the corresponding state machine object that we get back from this build method to reflect that. So we need to do a couple things here. First of all, look up the order, the existing one, this.order repository, find one by its order ID. And then we want to turn that into a key. So order ID key equals long.toString order get ID, and then we want to factory a new state machine. So order states order events SM equals this.factory. And we need the state machine factory. So this dot state machine factory. We don't have that injected here. So private final state machine factory, and it'll be order states order events factory. All right, good stuff. Look at that. So this dot factory dot get state machine, passing in the ID, and the ID is the order ID key. There, good. So that's our state machine. But again, this state machine hasn't been started. Remember how we used it before? We have to call start. We have to do all that stuff. But when we call start, it's going to start at submitted, and this order might be an order that's all but fulfilled, for example. So we'll have to do a few things here. We need to actually tell the state machine to reset itself to our particular state. So let's do that here. We're going to say state machine dot stop. First of all, we don't want it running. First of all, if it is already started. And then we're actually gonna say sm.get state machine accessor, right? This gives us the ability to do some things, to visit the nodes in the directed graph that is the state machine. So we can get the state machine accessor, and then we can visit all the regions, right? So again, when you think about a state machine, you need to understand that state machines can themselves recurse on other state machines. You can have nodes that then lead to other state machines, in a hierarchical sort of fashion, and so you have these are called regions. Each one of these state machines, nested or not, is called a region. And I want to visit each region. So I'm going to visit each region here. So I'm going to say do with all regions, and I'm going to provide a state machine function. So new state machine function, and the state machine function has a very simple apply method, and in there I'm given a SMA, a state machine access. So SMA, I'll say SMA dot reset state machine. So that's the first thing I'm going to do, is I'm going to make sure that we have a new default state machine context that takes as its first parameter here the state that I want our object to be in. So I'm going to extract. I'm going to look at the current state of the object, which is order.get order state, and then use that here. Okay, so I'm resetting. I'm telling the state machine that even though you're submitted right now, I'm moving you forcibly to whatever state you're supposed to be in, so that we can have a predictable progression from here. And then everything else can be null, right? So null for now, null, and null. All right. And of course, this can be a lambda, which is a nice thing to have. We might actually need this again later, so let's leave that as is. But we can certainly you can use the diamond syntax there from Java 7. All right, so we've got that now, and that I think should do it. So let's actually start up the state machine for now. Start it up and return it. Now, of course, the question that comes up is, how are we going to persist this record? How is this repository ever going to find that record in the first place? Something needs to take care to persist the state changes with the entity itself, right? So when the state machine changes, I want to update that state field on the JP entity. So here we need to add a state machine interceptor here. So we'll say SMA dot add state machine interceptor, new state machine interceptor, and this gives me maybe I should have used the adapter. We'll use the adapter here because there's a number of different callback methods, and it's order states and order events. All right, and get rid of that. Goody. All right. So we need to write the state into the database before every single state change, or we could do it after. I guess it really doesn't matter, but for our purposes, I'm going to write it down in the database. There's no reason that this method couldn't take place in the same resource local transaction. If you're persisting this is a state change that's going to happen in your JPA entity. There's no reason that this state change couldn't happen in the same context, in the same thread, as your business logic changes as well. But in this case, it doesn't really, you could also do it, you could also persist this completely separately from your entity, right? Okay, so pre-state change, what we're going to do is we're going to say that we're expecting a parameter to, a header to come in on the event that triggered the state change, right? This is why we showed you that message builder variant earlier on, the variant of sending an event into the state machine. You can send either the enum value, or you can send a Spring Framework messaging message with a header. And that header option is, let's assume that that's what we're going to use, because that has the ability to convey parameters, headers, right? Values that we can pass into the state machine, which we can use in this case to persist our data. So we're going to say that if the message that we are given here is not null, right? So we're going to say if it's present, then we want to do something with it. And what are we going to do? Well, we want to get out the ID. So the order ID is the value that we're going to get from the message.getHeaders.getOrDefault, and it's going to be called order ID -1. So we actually looked at this exact same thing earlier on, and we're going to say that optional.ofNullable, right? And if that's nullable, then rather if it's present, order ID, then we want to process it. So we have the ID, and if it's present, we're going to get the order equals order repository dot find one, and we'll put the order ID in, get it out of the database. We're going to update the state, so we're going to say order dot set state, and this state will be whatever state we're progressing to, and that state, of course, is passed into this callback here. So state.getID.name, write that out, right? Or we can actually just say set order state. I suppose that would have been easier. So set order state, there we go, dot get ID. All right, there's that. And we want to say order repository dot save. So order. Very good. Okay, so that's what's happening here. We've got a callback. When the state machine enters a particular state, we want to, right before it enters, we want to write down the state that it's going to arrive at. And, we want to do that. We want to tie that to the order itself, and we need to do that by linking our change to a parameter that tells us which order is affected here, right? So let's revisit our code here. Clean that up a little bit. All right. Good. So that's a bit cleaner. I like that. I'm all about clean code. So we've got now our state machine. We've got a state machine accessor. All of this is being configured on every brand new state machine, right? So again, the state machine is a very lightweight object, but we're going to do some very heavyweight things with it. We're going to talk to a database and persist its state very, very easily, though, right? It doesn't take a lot to make this, to tie the state machine's advances to state in our business logic. So we're going to get the best of both worlds. We get our business logic, which is clean. We get a definitive, state machine and a model of how these things are supposed to progress, and so on. So okay, good. Now let's see what happens if we run this. What happens, right? So we want to be able to. This will actually create a state machine that'll build a state machine here. We want to be able to change the flow, the state of the state machine. So maybe we could do this. Maybe we could actually say pay, and then here we could say we could have some property of how much was paid, string, I don't know, payment confirmation number, right? And then we could actually send a message. So we could say message builder dot with payload, and the payload, of course, in this case is the pay event, right? So order events dot pay, and the header that we need, of course, the one that we must have is the order ID. So there's the order ID, and we're going to build that message like so. But we could also have, things like the payment confirmation number, right? Set header payment confirmation number, or the price. I don't know, whatever. It doesn't really. We're not going to actually use this in this example, but it's nice to know that we could send that into the state machine, and then it could do, as we've seen before, anything it wants with that. So we're going to say machine or sm dot send events message. So pay message, payment message. All right. So that's the first thing, and we know it's going to be called order ID. So we can. This is actually ideally something that you extracted into a single field. So you have order ID header, right? You should have that as a constant somewhere, and then reuse that in the class. So private static final. There we go. Order ID header there, and you could actually have the same thing here. These are well-known types of headers. Good. Okay. So that's the payment method. What else do we want? We want this should go up, 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 up. Good. We want to have another method that fulfills it, right? So let's say we have same basic signature, fulfill. I'm going to call this fulfill, and maybe now the fulfill method takes the address of where you're going to, the parcel, where the address or whatever that you're going to send it to. I don't know. It could take anything. It could be whatever you want, right? Whatever other information you want to contribute to the object graph here. But for our purposes, let's just have a fulfill method and same basic structure, right? We're going to build our state machine, and we're then going to move it to a particular state by sending an event to it, right? So let's do that. All right. And in this case, we don't have the payment confirmation, so we'll say sm.sendEvent payment message, and this will be fulfillment message. All right, and return sm. Good. So there's our fulfillment method as well, payment and then fulfillment. Here again, keep in mind when we start up the state machine, we want it to get its state based on the state of the order, right? So what's going to happen here is we're going to trigger the change. That's going to create a new state machine here. The state machine itself is going to look up the record for the object in the database. It's going to unpack the event, the message state, the order state. It's going to make sure that by the time we reach this line, that this state machine is already in that state, right? So if it's in state fulfilled, the third one, then this state machine will reflect that before we get to the second line. Well, obviously in the second line, let's say it's in state paid or whatever, submitted. So it'll be in whatever state it's supposed to be in by the time it exits the this.build method. And then finally, we're going to move it to the next state by sending a message into it, and that is going to trigger this pre-state change thing, which is going to update the persistent state in the database. So all of that happens very, very quickly. We've now with this, we're reading the data from the order object. We're reading the state from the persistent order object and setting our machine to that. And with this, we're setting the changes or synchronizing the changes to the state machine to the order itself. So bidirectional persistence. All right, so we've got our order service. Let's use this in our runner here. Where's our runner? Here we go. So order, and then in the order, we're going to send a few messages, I guess. So we'll use the order service. We're going to say we've created a new one. Let's fulfill it now. So order.getID. All right. Oh no, we want to pay for it first, right? So pay, and we'll have the whatever. I don't know. uuid.random.toString. Okay. So there's our toString. Now, if we wanted to, we can actually look at the state machine for this. That's why we returned it. So payment state machine, and we'll say payment.statemachine.get event, get state rather, .get ID .name. We'll log that out after calling pay. Okay. Goody. So there's that, and we're gonna have another one here called fulfilled. So we're going to say fulfill, and we know that's not going to need that second parameter, so we'll use that after calling fulfill. And I suppose we should actually even have this up here as well. After calling create, let's poke at the state right after it's been created. So and in this case we don't actually have it, so maybe we should have returned it there, right? We could have actually had the state machine being returned there, but for now it's fine. Let's just leave it like that. Okay, so after calling fulfill, we can look at the current state as well. All right, fulfilled state machine. All right. Go. So what did we do wrong? Insert into order. Aha. Simple newbie error. Order is a reserved keyword in SQL, and I should have known that. So let's just change the JPA entity. Where is our JPA entity? It's down here. All right. Name equals orders. Sure. Good. Try again. All right. Let's see what we had. So, starting the state machine, started the one that had these 4 states. State changed from submitted to submitted, right? Yeah, to paid. Good. It's confusing. Maybe it's easier to look down here. So after calling pay, it's paid, right? That's the current state. After calling fulfill, did I send the wrong event there in the fulfill method? Right now in the logs it said, oh yeah, fulfill. So in the fulfill thing we have to send the right event. Obviously that's not going to work otherwise. So it'll just stay on the old state in the pay state, so, or in the paid state. Okay. So after we called fulfill, the result was that it was fulfilled. After we called pay, the result is that the state machine says it's paid. And if you, we can actually confirm this by looking at the object at each step as well, looking at the order itself. So let's do that. Where's my runner? Okay. We're going to look up the record as well. So this time, I guess we could have a method that just returns the order itself. So let's just go to the order service here and looks up the order. Order by ID, long ID. All right. So this dot find by ID, and we'll print that out. Okay. So the last 2 methods return the state machine, but not the order. But we just want to poke at it. We just want to see what's happening, just to prove everything's working as we expect. So here, we'll actually say logging.info order will be equal to order service dot by ID, passing in the order dot get ID. And this line, of course, we can duplicate down here as well. Run the code again. What did we get, huh? So order is equal to fulfilled. The state is equal to fulfilled there, and the state is equal to paid there. So you can see it's synchronizing the changes back and forth. All right, so we've just looked at just a very brief intro to Spring Statemachine. There's a whole lot of possibilities here, right? There's a new project called Spring Cloud Skipper, which I hope to also cover in another installment of Spring Tips. Spring Cloud Skipper is a way of deploying and managing the lifecycle, the state transitions of complex applications, right, into a cloud environment like Cloud Foundry or Kubernetes. And it has a need for a directed graph. There's a state where you deploy the app, it goes well, or you have to roll it back, right? That kind of stuff is currently right now hard-coded, but we think it'd be an ideal fit for something like Spring Statemachine. Maybe that'll happen, we don't know. There's uses for Spring Statemachine anywhere you want to be able to describe the graph separately. So I've written a fair amount of code here, but at the top level, what we care about is the fact that there's these well-known transitions, and they're predictable. You can interrogate it, you can print it out, you can store it, you can do all these things with that, and you have a common way of talking about these state transitions, right? This aligns your code with what the business is trying to do, right? All right, so with that, my friends, thanks so much for watching, and we'll see you next time.